and I know we're not supposed to talk too much about work here, but that's kind of the problem space I'm in. We touch a lot of different projects. You don't really have a lot of availability to code immediately. You know, they ask for it, then you get credentials 2 weeks after they want it. So I built a project that's pretty much just a reverse proxy into sites where you can then hijack different routes. It works really well for static routes, not really for dynamic pages or anything. So yeah. So if you're looking for it on NPM, has anyone used Node here? All right. So basically it's just JavaScript server side. At VML we don't really use it too much as a server, but I can tell you that almost there's a lot of developers using it for personal tools for themselves, in the way of like pre-compiled assets or anything like that. So that's kind of where this came from, is a development tool. It's not meant really for production. It's not meant for you to put it out there. So this came out of kind of having to touch a lot of different projects, and I'm not really a .NET developer, and that's my current project. So and as you can see, I'm using a Mac. I really hate opening my VM. I really hate getting into Visual Studio. We had a lot of assets tied into the CSS/HTML files and stuff. I've been pulling them out slowly, and eventually I had like an afternoon to sit there and go, oh sweet, I will never have to open this again if I make this little project. And it came together in about 2 hours maybe, and could have been more if I had planned maybe, or less if I had planned. So you guys are code people. I'm sure you want to see some code on it. So this is really all you need to have a reverse proxy server, at least the API that I've built. I want to say first off that I'm standing on the shoulder of giants. I did almost nothing to actually figure out how to do a reverse proxy in Node. That's the awesome part about Node. The package system and the environment out there is so saturated. You can find everything. Everyone's done probably something that you've done. It might not be as good as you want it. So when that happens, you know, submit a package. This was my first one that I've submitted to NPM that I've published, so pretty excited. The technology that this is built on is actually a Walmart Labs technology, and there's a guy here in town that came and talked to the local Node KC group. Really cool guy, and they built this crazy server called Happy. It's got, if any of you guys like Ren and Stimpy, that's the branding for it. So everything is Ren and Stimpy themed. It's pretty fun. Huge fan. And then it's a pretty good product on top of that. So I threw together a small example of like, okay, if I was asked to look at a site real quick and I don't really have availability assets, what would I do? So I chose Happy Midwest. Maybe a little brown nose in there. So if you open it up, I told Michael that I'm not trying to bag on a site or anything, like that wasn't the point, but it was awesome because he's got a JavaScript error right there. It's like, okay, someone asked me to fix a JavaScript error. Cool. So that's awesome. I think what it is just an order of includes, really, so that would be the ultimate fix. But if you didn't have, you know, a whole lot of availability into that, and you could only mess with scripts, say you wrote this incredibly crappy thing, never write set timeouts to control your assets and when things are being loaded, but basically jQuery, the $sign function, whatever. I'm sure you guys, if you know anything about JavaScript, you know jQuery. Wasn't loaded yet, so I just did set timeout, and I guess I should start up the server. So localhost 8080, I've got my site sitting right here, everything there, awesome. So Happy really lets you do what I'm doing fairly easily, and not too many more lines, but I kind of foresaw myself using this over and over again, so I really don't want to write the same stuff over and over again. I just want a really simple way to get into it. So cool. Let's apply this little really bad JavaScript fix that I did. So I have a method on Butchershop where you can basically the first argument is the server's route to what you want. And you can be a file, and the second one is on my computer what I'm redirecting it to, and I just kind of mimicked the file structure there, so I'm loading in that plugin. So let's save that and check out. Cool. Not the error we just had, but a different error. So that's cool. We got rid of one error. One showed up. So sweet, we fixed that error. I don't know, it didn't say, cool, we got updated pictures of prizes. All right, let's load some new prize pictures in. All I'm really doing here is redirecting to one picture because I didn't really want to find pictures of stuff, so I'm just looping through and creating a bunch of routes, or hijacking a bunch of routes and putting them to one picture. So let's check that out. All right. Sweet prize. Who wouldn't want that? So cool. We solved a bunch of problems pretty quickly. All right, now let's say someone asks you to, yeah, the site's really great, we like the layout, but we want to reskin. Oh no. So what's cool about Butchershop too is you can hijack routes. Hapi's kind of weird. This is pretty much their version of regex. It's not like full regex, but it gets the job done. It's simple enough to understand. Regex is kind of confusing to me as a front-end developer, but I don't know. I don't know who it's not confusing to. If it's not, you're a genius. I want to talk to you. So really, I'm just hijacking all the CSS loaded from hackthemidwest.com/CSS to my CSS. Sweet, looks great now. This will melt your computer after a little bit too. So yeah, just like jumping in, putting assets in, and dealing with maybe an existing site in production is awesome. It's really extremely easy to do. It's a lot more helpful if you develop in a like single page app style where you have like one entry point to your JavaScript or like one include, because then you've effectively like hijacked everything on the site. If you just got like required.js or something like that where that's managing your assets, or if you have one CSS file, it's typically the in production what you want to see. But what's awesome too, and what I've used it for at work is like if you've got a dev server, a stage server, and a production site, and you know, your dev server is foobar because you know all your services are messed up at the moment, just boot up Hapi and start hijacking routes from one of the other sites, because as a front-end developer, you know, it's really easy. I just need JSON, so I just need a source for JSON. So I'll just point data endpoints to those, so you can get those familiar. So yeah, that was pretty sweet when I realized I could do that. So yeah, this whole thing came together in about 3 hours time. I guess I haven't shown you any source code of what it actually is. Does anyone write coffee script? No? All right, it's indent-based JavaScript, precompiled. I think it's a lot cleaner. Gives you a little bit. Purists say boo to that, but I like it. So all of my kind of wrapper into Hapi that makes this happen is apparently 80 lines or so. compiled JavaScript, 126. That's why I like hapi. Yeah, incredibly simple. Publishing it was incredibly simple. NPM makes that really easy. Other than that, this is a ridiculously small project, so when you said I had more than 5 minutes, I got a little bit worried. I'm probably at 5 minutes right now. But really, that's about all there is for this thing. It was a really focused problem space and just easy to solve problem. So, you guys have any questions? No questions?
Does it run, I mean, what's the requirement? Does it run on a specific version of Node or?
No, I think my package file says 8 or 10. Oh, I say 6. So it goes all the way back to 6 probably fine. I probably haven't tested it that thoroughly. There's a few people at work who picked it up. I don't know, I saw on NPM that there's a few downloads for it. I don't really publicize it that much, but there really aren't that many issues on GitHub either. So all of them are my own issues for like, hey, come back to this and fix this, because people are downloading it. So yeah. Cool, guys. Thank you for letting me talk. Sorry I went so short, but yeah.
So, this is a series of modules that I built for data visualization. I decided to call it Hipatia. So first question is who? Well, let's see, how did that quote go? The 2 difficult things in computer science are concurrency and naming things. Is that right? So, Hipatia was one of the first documented women in mathematics, one of the ancient Greeks. So, to honor those who have come before, and because why the heck not, figured I may as well name this thing Hipatia. So, data visualization API, what the heck does that mean? Well, Perl has, well, if you're not terribly familiar with Perl, there's the CPAN, the Comprehensive Perl Archive Network, which has modules for anything and everything you want, pretty much. So this acts as a layer of glue between DBI, which is Perl's database independent implementation layer. So you have the drivers, you have DBI, and you don't have to care about the particular driver implementation. And one or more data visualization modules. So where this came out of is every time you want to keep track of something on a regular basis, or you build some kind of quick report for something, what are the steps? So you've got to reach into the database, munge the data that you want, cram it into whatever data visualization layer that you want, fiddle with options to get the chart to come out exactly how you want it, right? So this kind of compresses all of these into as little code as possible. Currently, I only have 2 data visualization front ends supported. Chart Clicker, which we'll see examples of both of these, but that's just more generic charting for line graphs, bar graphs, etc. And GraphViz 2 for that's an implementation of the GraphViz GraphViz algorithm put together by, I think it was AT&T and Bell Labs, for plotting graphs with nodes and edges and whatnot. So, look at a little bit of Perl here. And of course, I've got to this way. Can everybody see this okay?
Maybe a little bit bigger.
Yeah, let's see. What is that? Command plus?
Yeah.
Awesome. That looks good. All right, is that better?
Yeah. Yeah.
Okay. So, I've built, so this is just, I built a basic SQLite database. It contains a few small tables. This can work with MySQL or Postgres or anything else that you want. but just for the sake of this demo, I built a small thing with SQLite. So blah, 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 blah. So one of the tables in here is, and I didn't want exactly all made up data for this. So you can grab this online, the Dow Jones closing averages for, I think, every day since the beginning of the year. So what in the heck would happen? Do something a little bit fun here. What would happen if you tried to aggregate the max, min, and average closing values by number of weeks ago? So that's essentially what this query does. So the Hipatia object, I'm just telling it I want, please render with chart clicker, I want a line graph. The DBI part says this is the database part I want, this is the DSN, the database connection string, which for SQLite just basically the only important part is the file name. The query that you want, which is that thing up there, if you were using MySQL or something, you put in your username and password. The query has, well, when you use number of weeks ago for the x-axis and these 3 different y values. So got to put in this case, we'll put in advance what we want for x, what we want for y. It'll pick that out in the query. And for so this will produce 3 line graphs. And I want to name these, instead of min value, minimum, average, and maximum. So what this does is involves dependency injection. It grabs the extension for chart clicker, crams it in, grabs the data with the query, shoves it into a chart clicker object, which we call the graph method on it. And then once I have that, I can figure out where my cursor is. There we go. And then I can do things like, okay, this is the title text, width, height, and so on. And come on, there we go. And then I can just write it out to a file, dowjonesweekly.jpg. And let's in fact run that. And as you can see, I'm not pulling your leg. There are no graphics files in there. So I do that, and hooray, we've got a PNG file. If I can type. And we get a nice set of line graphs directly from the data.
That's depressing.
Thank you. So a couple more things that I wanted to demo. So I've got a table here, so we aren't using, we aren't going to use a particular query. I'm just saying grab everything in this table, and I just call the table scatter plot. It's just has 2 columns. So I'm not specifying a particular query, same database. We're going to do a point graph out of chart clicker. Notice I'm not specifying, unlike Dow Jones here, I'm not specifying the columns. There are only 2 columns here, so it will guess, and guess correctly in this case, that the first column it grabs is going to be the X, and the second column is going to be the Y. And of course, since databases don't have an inherent ordering for columns, this can be a little bit dangerous, but we'll live on the edge. So graph it, width, height, blah, blah, blah. So we run this. And hooray, we've got another PNG. Not, oh God, whoa, no! Okay, and you expected a line, didn't you? Ha, no. But yeah, shoves out the X and Y. Of course, this doesn't mean a whole heck of a lot without some context in the title and whatnot, but the label axes and all that can be thrown in separately. That's not a big deal. So that's some made up data. Also, this is an example with GraphViz. So this, again, we're just grabbing stuff from a table. This only has 2 columns, and this is a really, really teeny tiny social graph, denoting who's friends with whom. So it's just a bunch of names and 2 columns. So I'm going to want this. I want the graph to be directed. And just for the heck of it, I'll dump this out in SVG. So, don't reboot my computer. This is actually debug text that I forgot to take out of production when I last committed it. But actually, I'm glad I did this because this gives us, so the 2 column names are A and B, because that's so helpful. And this is how it grabs the data out of the database and stores it. So we've got essentially a hash of 2 arrays, right? And so undef is Perl's version of null. So Phil has no one that he's friends with for Phil. Alice is friends with Bill. Bill is friends with Alice, and so on and so forth. And we have an SVG file, and unfortunately it's set to open up automatically in supporting text, which is not what we want. So let us instead open up this sucker in Firefox, and there we go. So, just for the heck of it, here is, of course, this to me, gotcha. So here's a chart clicker example. If you just wanted to do this without Hipatia, first of all, oh God, I don't remember all this stuff. Okay, width, height, okay, cool. All right, this is my data, this is my X, these are my X values, and these turn out to be my 3 different Y values for completely different related graph. Oh God, data series? How am I going to remember this? Okay, I shoved them into a data set. All right, I guess I've got to add to the data sets. Context? Well, context turns out to be 1 or more data sets in case you want to cram like a line chart and a bar graph together. And then blah, 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 and that ends up getting you this line graph, but that's a lot of crud to remember. So if you just want a basic no-frills graph, this will grab the data, cram it in, spit out the graph that you want. So with that said, that pretty much concludes my demo. So this is available on CPAN. Those are the links there. Just search Hipatia. It's the only one. Questions, comments, insults to my family, hurled objects.
Your mother was a hamster. Okay. So on that first example you had, you outputted it to PNG, and the second one you got SVG. Is that pretty interchangeable? Can you specify that, or is there a reason why you did that?
You could, I specified for variety's sake. I could have put this out as a PNG as well.
Okay, cool. Yeah, I guess I've seen that delivered as well.
Yeah. You can also, I think even for chart clicker, you can specify, I think it's format. There are a lot of things I have left to do here. I want more front ends. There's a Perl hook into R called statistics R that I want to be able to hook into for this. Just haven't had the time. Also, I want to be able to get rid of things like this, right? So I can just do that strictly within the API, so I don't have to remember these things, as well as a uniform way to spit out the file.
You were talking about in the second example, adding the column,
so I could have said...
adding the chart names on the side. How difficult is that?
That is not that difficult. I just got to remember how. So let me do that. let's see, so this would be, sure. Oh, wait a minute, hold on. It's actually, I think one of the examples has this. So it's going to be easier than looking through the docs. Oh, come on. Really? There we go. Oh, maybe not. Oh, yeah. So you grab the default context from the chart clicker object, and then you set the range axis label to what you want, domain axis
So you
label to
just
what
set
you want.
those two labels.
Yeah, to whatever string you want. In fact, we can go ahead and do that real quick. Just for the heck of it. Save. Let's see, that was the scatter plot. Okay. And there, that's really small.
I see.
Lorem and Ipsum are there. So yeah, eventually, I did actually, I haven't actually touched the code or added features since December, so I did start on an options part where you can specify some of these things, but I don't want to make it too specific to chart clicker, so that's still kind of in progress.
You also talked, was it like a series of contexts for overlaying different types of charts? Are all your models, I can't remember what you were calling them, but are they all pretty much Cartesian plane type charts, or?
So these, for right now, it's going to be, yeah, stuff that you can
Okay.
display on a planar basis. As far as 3D charts, there's nothing here that really prevents that, right? It's just hooking in the API for the display.
But it's pretty interchangeable with whatever you want to do.
Yeah, so the main idea, let me go back here. So, back up. So Hipatia is just sort of the base thing. It provides all of the dependency injection. And then it just grabs whichever one of these distributions you're calling for the back end. So yeah, if you got some new, like GD or GTK or whatever, just all you need to do is make bindings for it. And figure out what columns mean what, and what defaults you want to have, and things like that. Other questions? Well, thank you for your time.
Great.
And my name is Juan Gomez. I'm an Android developer at OneLouder. I'm also the co-founder of Python KC, a Python user group that we have here in Kansas City. So I'm going to talk not so much about how to set it up, but what it is and what you want to try. So emulating a little bit what Michael Overstreet did on the last Hack and Tell when he talked about 3D printing, I'm also going to share my passion about hardware stuff as he did. So I'm going to show you what, how many of you have heard of the Raspberry Pi? Okay, everybody, great. So I'm going to tell you a little bit what it is, which I assume you already know, but I'm going to tell you the history behind it, and I'm going to compare it to Arduino and some of the most popular hardware, because those are the questions that I get all the time. The first question everybody has about Raspberry Pi is, what's the difference with Arduino? When want to use one or the other? Why should I buy a Raspberry Pi if I already have an Arduino? So I'm going to talk a little bit about all those things. So what I have on the screen is the Raspberry Pi. I put it on the screen for the sake of the video, but here's a live version of the Raspberry Pi. So as you can see, it's a small credit card sized computer. It's a full-blown computer, and it's also a project platform. We'll talk a little bit about what a project platform is in a little bit. It has a 7 megahertz ARM processor, ARM is the chip architecture that most of the smartphones that you guys have, smartphones and tablets that you guys have, run. It's a different architecture than x86, which is what your computer runs. So that's what the Raspberry Pi really is. It has the same chip or brains as your smartphone, but it's credit card size and it's meant to be a full-blown computer and a project platform. We'll talk a little bit about those. So why it was created? The creator of the Raspberry Pi is Evan Upton. He was a professor at Cambridge in the UK, and he was a professor in the computer science department. So he noticed that all the people that were enrolling in the 2000s to study computer science, especially this late part of the 2000s, didn't really have all the low-level skills that all the undergraduate students of the 1990s and 1980s had. So a bunch of professors got together and started thinking and bouncing ideas on why that was the case. Why the new students didn't really have all those skills that the previous generation of students had. And the conclusion they came to is that the previous generations of students were exposed to very friendly and very flexible computing platforms very early in life. That was the case here. That was the case here in the U.S. and that was the case in the UK too. Here you had the Apple I, which was a big board that you had to hook it up with a bunch of stuff. The Commodore 65, and not only computers, well, real computer platforms, but also a lot of game consoles and a lot of computers that were built as toys, and they were sold at cheap prices. So a lot of parents bought them for their kids, and so kids 7, 8, and above had access to a full-blown computer platform very early in life. So they start playing their games, but since these were computers very early in the late, very in the 80s and late 70s, they were not really very sophisticated. So kids had the opportunity to hack them and play with them and learn a lot of the low-level stuff. So when they grew up and enrolled in a computer science course, they kind of had that grasp already of all that low-level stuff. So they realized that was the problem of the current generation of students, and they said, well, what can we do about it? So they tried to create a cheap computing platform that they could put in the hands of kids so that they can have a computer and be able to hack and play and learn all those skills that the previous generation of computer scientists had. And I assume most of the people in this room, since we're in this business, I guess some of you or most of you had exposure to that as kids, and that's what probably got you hooked on. So that was the idea they had for the Raspberry Pi. But at the same time, there were two very interesting phenomena happening on the hardware world that contribute to the Raspberry Pi being a reality. The first was the Arduino that we have all heard about. The Arduino, as you can see, it's comparable in size. The Arduino Uno is a little smaller. The Due, which is the new one, it's a lot bigger than the Raspberry Pi. So the Arduino had a similar story. There was a teacher in Italy, and the Arduino is a microcontroller. It's not a full-blown computer. It's just a microcontroller. Microcontrollers are less capable, and so this chip or this board that you see here is what we call a project platform for microcontrollers. It allows you to prototype projects that you're going to create with your microcontroller before you actually put them in production. Microcontrollers are everything from coffee makers to refrigerators to all the appliances in your home because they're small brains. They're not as powerful as a full-blown computer, but they have a little bit of processing power in them, so you can automate simple stuff like what you have in appliances like a microwave or whatever. So the idea of chip manufacturers is that they want to basically sell you this prototyping platform so that you can create a product and then put it in mass production. So they want to get a lot of money up front to sell you the prototype, the project platform, and then when you put it in production and then you actually buy a large order to basically produce your creation, then they get a bunch of money. So project platforms used to cost upwards to $200, $300, and all the way up to thousands of dollars just for a chance to try and make a microcontroller and have all the additions that made it ready for you to play and create a prototype. So this professor in Italy, he had a bunch of artist friends. They were in theater or sculptures or a bunch of artists that wanted to create interactive stuff and engaging stuff for audiences. So what he said is, why or how can I create something that is affordable and accessible to them, but as powerful as a project platform from one of those big chip manufacturers? So he created the Arduino, which is basically just $25, and you get a full-blown project platform for you to hook it up to your robotics project or anything that you're working on. So this is meant to be a prototype platform, so it has very good capabilities as far as the voltages that it uses and the currents that it outputs, which is really important in electronic projects, and that's why it's being so popular. And the fact that the price is so cheap compared to the old platforms helped a lot. And then on the other side of the spectrum, there were a lot of people that wanted to make accessible computers for people to use. One of the first ones was the Chumby Hacker board. So what's the difference between a Chumby Hacker board? As you can see, it's a little bit bigger than the Raspberry Pi. So what's the difference with the Raspberry Pi and the Arduino? This is a full-blown computer, so it doesn't have the capabilities as far as voltages and output and currents and connections, especially as a project platform. So you have to create a lot of accessory hardware for it to function as a robotics platform or anything more sophisticated. It's just meant for you to hook up a keyboard, a mouse, and a monitor, and then use it as a computer. So the Chumby Hacker board, I'm not sure if you guys are familiar with the Chumby 1. The Chumby 1 was this little thing that a guy created probably, I don't know, 5, 6 years ago, probably more. He said, this internet thing is really great, so let's create an appliance that you can have at home that has the whole internet. Like an alarm clock with the whole internet that you can put on your bedside table and then be able to browse and check email and then listen to Pandora and stuff like that on this little appliance. So they wanted to bring the price down, and they created basically this platform that had an ARM chip, just like the one on your cell phone, so that they could basically put the whole internet in this little appliance. But they were so excited about what they created that they say, hey, let's make this available for hackers to play with too. So they created the Chumby Hacker board, which is this one, to sell. They had the appliance to sell to final consumers, and then the hacker board to sell to hackers that wanted to play and wanted a small Linux computer that they could put in their pocket. So what happened is the ARM chip that's on this board is a Freescale chip. Freescale is a big chip manufacturer. It used to be Motorola Semiconductors, but they spun off the company and now it's called Freescale. So Freescale started making a lot of money out of this little computer because the chips were selling really well. So the other manufacturers got a little jealous and they said, hey, we want into this game too. So Texas Instruments, TI, created what's called the Beagle board. The Beagle board is basically the exact same thing as the Chumby Hacker board, but it uses a Texas Instruments ARM chip. So they did that, they put it in the hands of people, but these computers are about $120, $125, so they are cheap, but they're not accessible to kids and schools and the people that the Raspberry Pi wants the computer to be accessible to. And it's a lot more complicated to get started than the Raspberry Pi. So those two things were happening. This computer platforms getting cheaper and more accessible, and also there was this big Arduino phenomenon of project platforms and people building everything from robots to I don't know, gizmos to brew beer, and all these different cool projects, and a lot of collaboration on the internet, and especially the open hardware movement. So those two things inspired the people that created Raspberry Pi and said, let's push it a step further and let's make it accessible to kids so that they have the skills we need them to have when they grow up and enroll into a computer science career or an engineering degree or whatever. So they created the Raspberry Pi. The Raspberry Pi is a combination of the two. It is a full-blown computer. It runs a full distribution of Linux, but it also has all the advantages of a project platform. So it has very high current values on the output of the pins. It can support higher voltages than one of the Xiaomi hacker boards, but it also has 2 USB ports and 1 HDMI out, so you can just hook up a monitor and a keyboard and a mouse and have a full-blown computer. They made it a lot more friendlier than the Xiaomi hacker board and the Beagle board. These boards run versions of Linux that don't even have an X server, so a UI with windows and stuff you can click on. So for Raspberry Pi, they went a step further, and they use a special distribution that's called Raspbian. It's derived from Debian, a very popular Linux distribution. So it has its own windowing environment, and it has a GUI, because most kids now, they get exposed early on to computers that actually have a GUI that they can click on and windows that they can drag. So they need to make it accessible so that they can start using it the same way they use their home computer, but then if they want to go deeper, they can. So one of the advantages when you boot the Raspberry Pi, the first thing you get is a desktop with Windows and everything, but it has access to a full-blown Python development environment. And that's the other thing that the creators of the Raspberry Pi wanted. They thought Python was the ideal language for kids and beginners to learn, but since this is a Linux computer, there is no restriction about you can only use Python. The same way that the Arduino, you can only use their Arduino language or the assembler for the processor. On a full-blown Linux computer, there's no restrictions. You can basically do anything. You can do the same thing that we saw today, the reverse proxy in Node, the data visualizations of Perl. You can run them on this little computer. There's no restriction. So they kind of added the Pi at the end of the name to make a nod to Python, but there's no restriction that you have to use Python. But you get the access to the Python environment right on the desktop for kids to start using it. And it also has a bunch of, there's a platform in Python called Pygame to develop games really, really easily. So it has a bunch of games on Pygame, so that kids can start using it as a gaming console and have little squirrels jumping up and down the screen. But if they like that, they can go and see the Python code and make the squirrels jump up and down and modify it so that they go sideways or whatever. So it's the idea is to entice them to explore and learn more. So it's 25 bucks, 700 megahertz processor. There's 512 megabytes of RAM, and there's 2 versions of the Raspberry Pi. And this is one of the questions that I get a lot from people that want to buy them. When you go buy them, there's Model A and Model B. So what's the difference between Model A and Model B? They both have the exact same processor. They're both credit card size. The biggest difference is the Model A has less RAM. So it only has 256 megs of RAM. And it also only has 1 USB port. And it doesn't have a physical Ethernet port. So, but the advantage is, without those things, with less memory, without the Ethernet port and the extra USB port, they were able to get the price down to $25. So it's 10 bucks cheaper, but you get a little bit less than what you get with the Model B. So if you have the $35, get the Model B, which is it's ready to be a full-blown computer platform because you have the keyboard and the mouse, and you also have the Ethernet port, so you don't have to buy extra stuff. If you Google Raspberry Pi online, you're gonna one of the hits on the first page of Google is an article called "The Hidden Cost of the Raspberry Pi." The title is a little. They want to basically grab people to read it, but what they're saying is, you get lured into Raspberry Pi thinking it's just 35 bucks, but it's not. You have to spend a lot of money to actually get it to work as it's intended. But it's really not that bad. So when you get the Raspberry Pi, the OS runs on an SD card, just like this one. But when you pay the 35 bucks, you don't get the SD card. So you have to pay $7 to get the SD card and load the OS. So that's 35 and 7, that's 42, and then costs start adding up. It also doesn't come with a charger, so you have to go and buy a charger. It's $5, so it doesn't really matter. The idea when they produce these is that a lot of the stuff that you need, you would have them at home. So the charger that it uses is a micro USB charger, exactly like the one you have for your cell phone. So the idea is you don't have to go and buy one because you already have it for your cell phone. A lot of us have SD cards for like our point and shoot, and or if we had a PDA or a Palm long time ago, we probably have a bunch of these laying around the house. So 4 gig, you need at least 4 gigs, but you can go as big as 32. So you need, the basics is you need this for the operating system, and you need a charger to basically power it. And then you can start playing with it. After that, you're probably going to need an HDMI cable if you want to hook it to a monitor, and that's extra cost, and then a keyboard and your Ethernet cable and everything else. So basically that's what it is, that's the history behind it. I just want to show you a couple of very cool projects and then get some questions. So this is a project that was shown at Python, the Python conference that is held every year. They basically created a polling system. They connected a Raspberry Pi, this Raspberry Pi, to this little GSM modem. And all the code and how to set it up, it's on that page. The page is raspberrypi.io. And then you sign up and you have access to the projects. They have this little modem and connected to the Raspberry Pi. And then you can text. They have like a running live poll. So you can text what's your favorite Python web framework to a number, and then that text gets read in real time by the Raspberry Pi, and then this bar chart that you see here gets drawn using Pygame, the gaming platform that's built into the Raspberry Pi, so that you can see the graphics of the bar chart. So that's a cool project that's on Raspberry Pi.io. There's also a really cool project on Raspberry Pi.io that this is something that one of the Python KC members actually put together. There's a cell phone called the Motorola Atrix. I don't think they sell it anymore. The Motorola created this, what they call a lapdog. It's basically a laptop that has no brains on it. So you hook up your Motorola cell phone, and then that becomes the brain of the laptop, and then you have a laptop with your cell phone. So someone said, what if I don't hook up a cell phone, and instead I hook up a Raspberry Pi? So that's what they did. Through the HDMI and the USB, they hooked it to this little lapdog. The lapdog is $79.99 on Amazon. You can still get them. And then you hook up your Raspberry Pi, and you basically have a laptop. So it's a cheap laptop, under $125 if you buy everything else. So it's reasonably cheap, especially if you're going to give it to a kid, maybe to play around. You don't have to spend money on an extra monitor or carry around monitors and cables and a bunch of other stuff. You can have your little neat laptop. And then this is another project that another of our Python KC members created. It's called NASberry Pi. So basically it's creating a NAS, a network storage server, basically, using a Raspberry Pi. So this little guy becomes your media server at home. So you can have it, you can hook it up to your TV, you can have it downloading movies from the internet on the background, and then when the movies are downloaded, you can stream them to your TV. And then if you have something like an Xbox, I think it's the Xbox platform, the one it supports, I'm not real sure. So if you have something like an Xbox, you can stream it to the rest of your home, to the rest of your TVs at home, and you can watch the movies that you download here, and you can also download or upload other stuff to the internet. So it becomes your little media center for your home just for $35, which is really amazing. So it's a really cool project that someone here in Kansas City created too. So more than just showing you and the projects, my invitation is to, if you have the money and the curiosity, go get one. It's just $35. Most of the stuff you need, you probably have it laying at home. And better yet, go get it for your son, go get it for your daughter, go get it for your niece or your nephew as a Christmas present, as a birthday present, and encourage them to learn and use it and play with the little games, and hopefully we'll have a future generation of little computer scientists that have the skills that we need. And the last thing I want to say is, if you're interested to learn more, especially the Python part and how to use Pygame, I'm going to be giving a talk at KCDC, the Kansas City Developer Conference. It's May 4th at 9:40. So if you want to stop by and say hi and learn a little bit of how you can build games on the Raspberry Pi, you're welcome to come. So thank you very much. Do you guys have any questions?
Where do you get it for $35?
Well, that's also the catch. It costs $35, but then if you get it, there's a website called Element 14. You're gonna have to pay the shipping. If you want to buy it and if you want to buy accessories, I really encourage you to go to Spark Fun, which I'm wearing their t-shirt today. They're a startup based out of Boulder, Colorado. They sell a lot of the hardware you need to get started with the Raspberry Pi, and they also, with the money they make, they also have a little hacker community that teaches people how to play with hardware. They also have a bus that's going all around the U.S. right now, and they basically, for a very small fee, for schools, they give the schools a bunch of hardware for the kids to play and learn to keep it and take it home, and then they have a full day of their instructors to teach the kids how to use it and how to build cool stuff. So they're making very, very cool stuff. So it's nice that the money that you're putting into this, you also know that that's going to good causes. There's also a startup in New York called Adafruit that is doing the exact same thing. They're putting a lot of their tutorials online on how to get this set up and how to get this working. So if you buy from these two vendors, some of the proceeds are going into furthering this cause of opening up hardware and hacking platforms to kids and to a lot of people. You can also get them on Micro Center, and you can also get them on Element 14. I just think these two distributors are what they're doing is really, really cool, and I would like you to help them out. So yeah, it's $35, but you're gonna have to pay for shipping, and so if you have the money, if you want to make it worthwhile, get some accessories while you're at it, and that'll make it worth your while.
It's real depressing to get one and not have it, and you're like, oh.
But you probably have a lot of stuff at home too, so.
Just start taking your stuff apart.
Yeah.
Take your thermostat apart. That's fine.
So any more questions? Okay, thank you very much.